How are you, my dear viewers? I hope you will be fine. It is exercise 1.3 of the chapter Functions and Limits. We are going to attempt a very important question of this exercise. It is part 9 of question number 2. The function is x raised to power n minus a raised to power n divided by x raised to power m minus a raised to power m, and the limit is x tends to a. Before solving this question, we must know the result of an important limit. This result will be used in above question. And the important limit is this. What will be the result? So we must know the factors of x raised to power n minus a raised to power n. So we proceed like this. X square minus a square will be x minus a and x plus a, and x cube minus a cube will be equal to one factor is x minus a and the other will be x square plus ax plus a square, and x raised to power 4 minus a raised to power 4, the one factor is x minus a. What will be the other factor? So we find the other factor like this. X raised to power 4 minus a raised to power 4 divided by x minus a. It is x raised to power 4 and it is x. We go to x cube. We multiply this. X raised to power 4 minus ax raised to power 3 minus plus ax cube minus a raised to power 4 plus a is not here. We need a and x square. Ax square, ax cube it will become minus a square x square minus plus a square x square minus a raised to power 4. You need a square and x because you need x to complete a square x square plus a square x. It is a square x square minus a cube x. A cube x minus a raised to power 4. It is a cube and x. X is here also. Only you need a cube plus a cube. This will become a cube x minus a raised to power 4 minus plus, and both the factors will be cancelled. Therefore, the other factor in x raised to power 4 minus a raised to power 4 is, one is x minus a, other factor is x cube plus ax square plus a square x plus a cube. And similarly, if we go on raising power and reach up to x raised to power n minus a raised to power n, its one factor is x minus a. Then what will be the other factor? The other factor, it is x cube, mean n was 4 and it is n minus 1, it is 3. X raised to power n minus 1 plus a into x raised to power n minus 2 plus a square into x raised to power n minus 3. N is 4. 4 minus 3, 1 power. And go on. Then we shall get x a raised to power n minus 2 and a raised to power n minus 1. This is last. Therefore, this limit we can write here again. Limit x tends to a, x raised to power n minus a raised to power n will be x minus a equal to x minus a into x raised to power n minus 1 plus a x raised to power n minus 2 a square x raised to power n minus 3, and the last is x a raised to power n minus 2 plus a raised to power n minus 1 divided by x minus a. Here is limit x tends to a. Okay. This factor will be cancelled with this, and we get limit x tends to a, x raised to power n minus 1 plus a x raised to power n minus 2 plus a square x raised to power n minus 3 plus x a raised to power n minus 2 plus a raised to power n minus 1. How you get n minus 1 is the last. From where? From here we got a raised to power 4 here. It is a raised to power 3. What is this? It is n minus 1. The last value is n minus 1. Here a raised to power n minus 1. And it is a raised to power n minus 2 before the last. Before the last value, a raised to power 2 n minus 2, and it is x. A raised to power n minus 2. It is 2 and n is 4. Therefore, it is n minus 2 and x. This is the last term. Last two terms. So now we are in a position to put the limit here. A raised to power n minus 1 plus a into a raised to power n minus 2 plus a square into a raised to power n minus 3 plus a into a raised to power n minus 2 plus a raised to power n minus 1. A raised to power n minus 1 plus a raised to power 1 is here and n minus 2 is here. N minus 2 plus 1, it becomes n minus 1. Here a raised to power n minus 3 plus 2, it is n minus 1. Plus so on, we get a raised to power n minus 2 plus 1, n minus 1, and also it is n minus 1. How many terms are these? These are n terms. The power is n. Here power was 4. There were 4 terms here. It is power 3. And there are 3 terms here. So therefore it is power n and there are n terms. We can write n a raised to power n minus 1. Limit x tends to a, x raised to power n minus a raised to power n x minus a. I hope you will be happy with this procedure because you will never find this procedure in any book, and hence we write the result here. Limit x tends to a, x raised to power n minus a raised to power n divided by x minus a equal to n a raised to power n minus 1. We shall use this result in question number 9. This is question number 2, part 9. It is limit x tends to a. The function is x raised to power n minus a raised to power n divided by x raised to power m minus a raised to power m. We rewrite the limit. We need x minus a here in numerator and also here in numerator. So we do dividing numerator and denominator by x minus a. We get limit x tends to a, x raised to power n minus a raised to power n, x raised to power m minus a raised to power m equal to limit x tends to a, x raised to power n minus a raised to power n divided by x minus a, and x raised to power m minus a raised to power m divided x minus a. So you may take the limits separately. Limit x tends to a, x raised to power n minus a raised to power n divided by x minus a. Limit x tends to a, x raised to power m minus a raised to power m divided by x minus a. It makes no difference. By dividing x minus a, this will be cancelled. We have divided the numerator and denominator to get our result only. Okay, this will, what will be the result of this? It is n a raised to power n, a raised to power n minus 1. This is variable n. It is m a raised to power m minus 1. So we can write n by m a raised to power n minus 1 into a raised to power minus m plus 1. We take n up. A raised to power n minus 1 minus m plus 1. We have n minus n oblique m a raised to power n minus m. This is the answer of this question. I hope you have understand this question and you will be able to do yourself such type of questions. Okay, have a good day.